Good morning. Myself Praparanjay, working as an assistant professor in EC Department at Science College of Technology. In this lecture video, I am going to discuss about the design of low-pass digital chebyshev filter from Unit 2, that is IAR filter design in digital signal processing. Okay, let me discuss. Okay. For designing a chebyshev IR filter, IR digital filter, either analog filter is designed using the given specification that the analog filter transfer function is transformed to digital filter transfer function by using either impulse invariant method or bilinear transform technique. We know two types of methods we are using to transfer from analog filter to digital filter. That is, first method is impulse invariance method, and either a second method is bilinear transformation technique. The analog chebyshev filter is designed by approximating the ideal frequency response using an error function. The approximation function is selected such that the error is minimized over a band of frequencies. Okay, there are two types of chebyshev approximation. We know type 1 chebyshev approximation, and another one is type 2 chebyshev approximation. In type 1 approximation, the error function is selected such that magnitude response is equable in the passband and monotonic in the stopband. In type 2 approximation, the error function is selected such that magnitude response is monotonic in the passband or equable in the stopband. Type 2 magnitude response is also called inverse Chebyshev response. Okay, the analog Chebyshev filter. The magnitude response of type 1 low pass filter is given by squared magnitude of h of j omega equal to 1 divided by 1 plus epsilon squared c suffix n squared into omega divided by omega p, where epsilon is called the attenuation constant, and Cn omega divided by omega p is Chebyshev polynomial of order n. Okay. The transfer function of the analog system can be obtained from the magnitude response of type 1 low pass filter by substituting omega by s divided by sj. H of s into h of minus s equal 1 divided by 1 plus epsilon squared cn squared s divided by j divided by omega c. For the normalized transfer function, let us replace s divided by omega c by sn, which means h of sn into h of minus sn equal to 1 divided by 1 plus epsilon square cn square minus j into sn. Okay. For a stable and causal filter, the poles would lie on the left half of S-plane. Hence, the desired filter transfer function is obtained by selecting n number of left half poles. When n is even, all the poles are complex and exist as conjugate pair. When n is odd, one of the pole, n is the order of the filter, n is odd, one of the pole is real and all the poles are complex and exist as conjugate pair. Therefore, transfer function is Chebyshev filter will be a product of second order filters. Okay, and let me see normalized Chebyshev low pass filter transfer function. N be the order of the filter, we know already. H of Sn be the normalized Chebyshev low pass filter function, transfer function. When n is even, the formula for h of Sn equal to k equal to 1 to n by 2. Capital B suffix k divided by Sn square plus bk Sn plus ck. when n is odd, h of Sn equal to b naught divided by s plus c naught, k equal to 1 to n minus 1 divided by 2, bk divided by sn square plus small bk sn plus ck. Okay. Okay, where bk equal to, small bk equal to 2 into y suffix k, capital N into sine of 2k minus 1 into pi divided by 2n, where ck equal to yn square plus cos square 2k minus 1 divided by pi, sorry, into pi divided by 2n. C naught equal to yn, where yn equal to 1 divided by 2, 1 divided by epsilon square, that is passband attenuation parameter, plus 1 whole power 1 by 2 plus 1 divided by epsilon whole power n, minus 1 divided by epsilon square plus 1 whole power 1 by 2 plus 1 divided by epsilon whole power 1 divided by n. We know n is the order of the normalized Chebyshev filter transfer function. Like we see, normalized Chebyshev filter, low pass filter transfer function. N is the order of the filter. This is the for n value is even, h of n equal to h of sn equal to 1 divided by 1 plus epsilon square whole power 1 by 2. For odd, h of sn equal to 1. Okay. For unnormalized transfer function is obtained by letting Sn tends to S divided by omega c. The normalized transfer function, where omega c is cutoff frequency of the low pass filter. H of S, the normalized Chebyshev filter, low pass filter function, transfer function, where when n is even, H of S is obtained by letting Sn tends to S divided by omega c is normalized Chebyshev low pass filter. H of S, this is the formula for transfer function. H of S equal to k equal to 1 to n by 2 bk divided by sn square plus bkn plus ck, where Sn equal to S divided by cutoff frequency omega c. Okay. Normalized low pass filter transfer function h of s, we know n is the order of the filter, omega c is the cutoff frequency, where n is e odd, where n is odd, this is the formula for the transfer function. H of s equal to b naught divided by sn plus c naught, k equal to 1 to n minus 1 divided by 2 bk divided by sn square plus bk sn plus ck. Here we have to substitute Sn equal to S divided by omega c. Okay. And order of the analog low pass Chebyshev filter, n1 equal to cos h inverse 1 divided by as, which means attenuation, stop band attenuation is as, pass band attenuation is ap, 1 divided by as square minus 1 divided by 1 minus ap square minus 1 whole power 1 by 2, which is the numerator term, and divided by cos h inverse, denominator term is cos h inverse omega s stop band frequency divided by pass band frequency, that is omega p. Okay. Okay. The specification of the filter is given in terms of attenuation at a passband and stop band frequency. Okay. n1 equal to cos h inverse 10 to the power 0.1 into alpha s minus 1 divided by 10 to the power of 0.1 into alpha p, which means passband attenuation, divided by cos h inverse omega s divided by omega p. Okay, this is the magnitude response. For n is odd, for n is even, magnitude response of the Chebyshev filter, both type 1 and type 2. This is the cutoff frequency omega c equal to omega c into cos h 1 divided by n cos h inverse into 1 divided by epsilon. And where omega p is the passband frequency, omega s is the stop band frequency. This is the digital omega in radian per second, and ap and as is the attenuation of the passband frequency, attenuation at the passband frequency, gain at the stop band frequency, and capital T is represent the sampling time in seconds. We know capital T is time period is inversely proportional to the frequency. Okay. And omega p omega s is the analog frequency, last one. This omega p was omega s, both the analog frequency, and p is represent the omega p is represent the pass band frequency, and omega s is the stop band frequency. Okay. Choose either bilinear or bilinear transformation technique or impulse invariant method to determine the specific of equivalent analog filter. The gain and attenuation of analog filter is same as digital filter. By here, two formula is there. One for bilinear transformation technique and another one for impulse invariant transformation technique. For bilinear transformation technique, omega p equal to 1 divided by t tan omega p by 2, omega s equal to 1 divided by t tan of omega s by 2. Similarly, impulse invariant transformation technique, omega p equal to omega digital omega p divided by t, omega s equal to digital omega s divided by. Okay, this is the order of the filter formula. Order of the filter, capital N1 equal to cos h inverse 1 divided by a square minus 1 divided by 1 divided by a p square minus 1 whole by 1 by 2 divided by denominator term cos h inverse omega s divided by omega p. Okay. When n is even, we have one formula, and n is odd, we have another formula. Uh, yeah, this is we discussed earlier. Okay, n is the order of the filter, and odd and even. And it is frequency response. So p power j omega determine the transfer function of digital h of z using suitable transformation to transform h of s to h of z. Analog transfer from the analog transfer to convert analog transfer function to digital transfer function, we are using two method. First one is bilinear transformation technique, another one is impulse invariance technique. Okay. Okay. If you have any doubt in this topic, you can ask through comment. Okay. We will meet you next video. Thank you.